Hi everybody, I am here to talk to you today about the energy pyramid. Okay, so the energy pyramid is thinking about food chains, food webs, and how energy moves through them. So first, to remind you, essentially all energy on the earth comes from the sun. And so this is light energy coming from the sun and being absorbed by producers. And so let's label all of our levels. Producers, otherwise known as plants. We've got primary consumers. And we can think of those as our herbivores. Secondary consumers. So these can be carnivores or omnivores. Just really depends on what level we're looking at. Traditionally speaking, these are carnivores because secondary consumers eat primary consumers. And then we've got the tertiary consumers. These are our top predators. Now, of course, there can be more than 4 levels in an ecosystem. You can have incredibly complex food chains that have a plant being eaten by something, up and up and up. Okay, but we just draw this to give a representation because what we're going for is an average here of what we're seeing in life. Okay, so you've got light energy that's hitting the earth and plants are absorbing that. And so plants have 2 things they can do when they absorb light energy and, they do photosynthesis clearly. So the plants perform photosynthesis, but once they make that sugar, they can do 2 things with it. They can build biomass, just like the lab that we had, or they can use the energy to fuel cell processes. And you might be like, oh my gosh, what does that even mean? Well, your cell is always moving stuff around. It's replicating DNA. It's growing bigger. It's communicating with other cells. It's making proteins. It's doing all sorts of stuff that require ATP. Okay? And even in plants, even though they're not technically moving, they're still growing and responding to the environment and doing all sorts of stuff. So they need energy. And when that energy is used to fuel cell processes, ultimately the energy is lost. The energy is subject to entropy and it devolves into lower forms until it's lost as heat. And this is 90% of all the energy ever taken in by the plant is lost as heat. 90% of that sunlight energy the plant ever takes in is lost as heat. 10% is used to build biomass. That's it. So the plants we see, the trees we see, the grass we see, of all the energy the grass in the parade field ever took in, 90% of that was used to fuel processes and ultimately released as heat. Where does that heat go? That heat goes all the way up into the atmosphere and ultimately out to space. Okay? And only 10% of that sunlight energy was used to build biomass. And so let's label this. Let's say that the plants used 1,000 units of energy. And we're just doing this nice round number. It's tons, way more energy. Okay, if they used 1,000 units of energy, 900 of those units are being released as heat. 100 are being used to build biomass. Think of it this way, then. Another way to think of it is like money. If the plants have a $1,000 paycheck, they're spending $900 of that paycheck to do the things they need to do to live. Like, for us as humans, it would be eating and paying rent and paying car insurance and gas and entertainment and all of that stuff. Okay? And then what the plants are putting in their savings account, right, is their biomass is $100. So it's just 10% of that. So when a primary consumer goes to eat a plant, they don't get any of this. This is already spent. This is already used. That 90% of energy is already gone. They only get the biomass. That's what goes up. And so primary consumers can't access this 1,000 units of energy. They can only access 100 units of energy. That's it. Okay? Because they're only eating the biomass from the plants. All of this heat energy was gone, used up. So then the primary consumers can do 2 things with all the energy they take in. They can build biomass. And of this 100 units of energy, so like if they got a $100 paycheck, they're only saving $10. They use 10% of the energy to build biomass, and then they use energy to fuel cell processes and motion, movement. They're running, they're jumping, they're swimming, they're flying, whatever they're doing. And so all of that used energy is lost as heat due to entropy, right? This is because of entropy, entropy. This is 90% is lost as heat. And when we're talking about energy, this is all the energy those primary consumers ever took in. This counts all energy ever taken in. So this is not like a momentary, boom, we lost 90% as heat. It's the primary consumers eat, and they eat, and they eat, and every time they eat, 90% of the energy they eat fuels their body for the things they do day to day, and 10% gets put in the savings account to build biomass. So now when a secondary consumer eats a primary consumer, so let's see if we have like grass, and we have a grasshopper eating the grass, and maybe we have a mouse eating the grasshopper, that mouse can only access the biomass. That's it. They can't access this energy that's already been spent. Just like if somebody were to rob you after you had spent your money, they don't get the money you spent, they only get the money that you had saved. Like, so if you had made $100 and over the course of the week you spent $90 to buy food and pay for things that you needed for life, and you had saved $10 at the end of the week, if somebody robbed you, they're only getting your $10. That's it. I hope that metaphor makes sense to people. Okay, so the secondary consumer, say a mouse perhaps, so we can write this in. We've got grass, and we've got an insect. We've got a mouse here, okay? That mouse, when it eats the insect, can do two things. That mouse can build biomass. So it's going to use 10% of that energy to build biomass. And how much is it really getting out of these 100 units? Now, the mouse is only getting 10 units of energy. It uses 10% of that to build biomass. And then it uses energy to fuel cell processes and motion. And remember, because of entropy, that energy is ultimately lost as heat. Okay? And remember, this isn't lost as heat at one moment. It's all the energy ever taken in by that mouse. 90% of that energy that mouse eats during its whole life is used up because the mouse runs around, and the mouse does cell things, the mouse grows bigger, the mouse maintains its body, the mouse grows fur, all of that stuff is using energy to do. Okay? And so only this 10% that was saved as biomass is something that can be accessed by a top predator. So say the mouse is eaten by an owl. Take it to our owl lab. The owl can only access that biomass, and so that owl only gets 1 unit of energy from each mouse. And the owl does the same thing, 10% to build biomass. And again, 90% lost as heat due to cell processes and movement or motion. Okay. And someday that owl will die, and that owl will get eaten by a decomposer, and the decomposer only gets 0.1 units because the decomposer can only access the biomass. So the main take home from this whole energy pyramid is a couple things. First of all, anything that is consuming energy uses most of the energy just to live, and that energy ultimately gets given off as heat. This 90% number is an average. It's not exact. You have to do the exact numbers for each animal, and plant. We don't learn how to do that in this class. You'd only do that if you're a specialized food scientist, okay? But almost all the energy is used to fuel the body and given off as heat. 10%-ish is used to build biomass, and that's the only thing the next level has access to is the biomass. That's it, okay? Because all of this other energy was given off over that animal or plant's entire lifetime. So if there's 1,000 units of light energy that get taken up by the plants, Insects only have access to 100 units, and the mouse only has access to 10 units, and the owl only has access to 1 unit. Do you think the owl can survive just by eating one mouse? No, that's why this level of secondary consumers is bigger than the top level, because you need more mice to feed one owl. And you need more than one insect to feed a mouse. You need an even bigger primary level, and then an even bigger producer level, because you need a whole lot of grass to get up to one owl because of this loss, because so much of this energy is lost as heat. Okay? I hope this makes sense. Please let me know or your teacher know if you've got questions. But this, in a nutshell, is the energy pyramid that you need to understand. Again, to remember that there are 2 big things we do with the energy we take in. We fuel our body, and that is almost all of what you do with your energy. When you eat lunch, when you eat dinner, you are mostly fueling your body processes. And then a little bit gets used to build the biomass and get stored in your body. And the only thing that every level up can access is the biomass you built, aka your stored money. They can't access all the money that you've always spent. So I hope that is helpful. Thank you very much for your time.